Welcome to SolidWorks for the Engineering Design Process, Introduction, Section 1. These videos are intended to introduce you to engineering design with SolidWorks. You'll learn about the engineering design process and how to utilize 3D computer-aided design to conceptualize, visualize, test, and share your product designs, all while keeping the environment in mind. SolidWorks is a 3D computer-aided design program that allows you to create, simulate, publish, and manage your designs. SolidWorks software products are easy to learn and use, and work to help you design products better, faster, and more cost-effectively. The SolidWorks focus on ease of use enables engineers, designers, technologists, and students to bring their designs to life. You can use SolidWorks to create three aspects of your design: a part, an assembly, or a drawing. A part in SolidWorks is a 3D representation of a single design component. An assembly is a 3D arrangement of parts and/or other assemblies. A drawing is a 2D representation of your part or assembly. These videos first introduce you to the SolidWorks environment. You'll then learn how to build a part in Lesson 1. In Lesson 2, you'll build on your knowledge of parts to construct an assembly. Lesson 3 will cover how to create a drawing to communicate the specifications of your design so that it can be manufactured. In Lesson 4, you'll learn how SolidWorks sustainability empowers you to analyze the future environmental impact of your design. Finally, in Lesson 5, you'll test your design by using the many simulation features included in SolidWorks. Since these videos will emphasize good engineering design practices, it's important for you to know what the engineering design process is and how SolidWorks can help you through each stage. Engineering design can be defined as the process of developing plans to manufacture or construct devices, processes, structures, or machinery which helps accomplish certain needs. In simple terms, engineering design is the application of technical knowledge towards the creation of something useful. The engineering design process is a series of iterative steps that engineers and designers take to solve a problem. The engineering design process consists of 8 steps, each addressing different questions regarding the overall design. Step 1 is to identify the need or the problem. You need to ask yourself what problems exist in society that can be solved with engineering and what processes can be improved through engineering. Step 2 is to research the need or the problem. You'll need to look at existing solutions and analyze why they're not adequate. If you plan to create a completely innovative design, analyze if it will be viable. You need to talk to the client as well as the potential users of the product to determine the design requirements. At this stage, you should also establish the constraints and limitations of your design. Step 3 is to develop possible solutions. Coming up with an optimal solution requires analytical thinking coupled with creativity. When going about developing solutions, you should explain the design problems to others, as their input may lead to ideas. You can also conduct a brainstorming session and be open to even ridiculous propositions, as they may spark meaningful ideas. SolidWorks can help you immensely at this stage by allowing you to take your ideas and create a design. It allows you to visualize the final product, which will help increase accuracy and lead to a better product. Step 4 is to select the best possible solutions. You can use several different decision-making methods to justify a particular design. One example is systematic decision-making, where 2 choices are compared and the advantages and disadvantages are evaluated. Another is computational decision-making, where the importance of certain criteria is ranked and compared. You can obtain quantitative and qualitative data about your design from SolidWorks, coupled with a decision-making method to make educated judgments on which is the best design. Step 5 is to construct a prototype. Sometimes prototypes are created directly from a part or assembly through a rapid prototype machine. Usually the 3D design concept is transformed into a 2D drawing. SolidWorks can automatically generate a drawing from your 3D parts and assemblies. The drawing is then given to a machinist or manufacturer who will construct the product according to the specifications outlined in the drawing. Step 6 is to test and evaluate the solutions. At this stage, you'll test to see if your solution meets the design requirements and if any changes are necessary. This is most commonly done through simulations and motion analysis. SolidWorks provides many tools to help you test your products for flaws and deficiencies. If it's feasible, you should then conduct real-world testing because it can reveal issues that the simulation may have overlooked. Step 7 is to communicate your solution. At this stage, you present your solution to your superiors or the public. SolidWorks offers many tools, such as animations, which can help you during a presentation. SolidWorks can also help improve collaboration by allowing team members to access SolidWorks files. You can use these features to send drawings to your peers and effectively communicate your solution. Step 8 of the engineering design process is to redesign. Determine if your solution meets the criteria specified earlier in the design process. If not, find out which aspect of your solution can be improved. If your solution does meet the design criteria, you should still attempt to improve your design by making it more environmentally friendly and cost-effective. These 8 steps make up the engineering design process. These steps are repeated as often as needed until all the parties involved are satisfied with the solution.